There's a number of places you can start. The most common place to start is a board. And we all have access to boards thanks to the Industrial Revolution. And so this is a piece of oak. Now the issue with boards is they don't necessarily have straight grain. They're sawn. And so turning is much more forgiving of that not straight grain, that grain run out, than shaving with a draw knife would be. Because most of the shaving is going across the grain. But there are places where it will not be ideal. And so we want to maximize whatever straight grain we have. This looks pretty good. You can kind of count the number of ellipses. So we've got one down here and one up here. And if they're further apart, you probably have less grain run out in a flat sawn board like this. So that's one of the things to look at when you're picking out lumber, is for these ellipses to be as far apart as they can. These angles on the side are not necessarily the grain direction. A lot of people want to, when they saw it out, would want to follow those lines, but they are a function of these semicircular curves, the growth rings, intersecting a flat plane, the sawn surface of that board, and so that may or may not be the way the grain is actually going. So one of the best ways to figure out where the grain is actually just to split the thing in half. So we're just going to put the hatchet on it right like that and give it a good whack. And you can see that it's coming close to following the lines over here, but it's not nearly at all parallel with the lines over here. I don't know if you can see that crack, but it's these lines over here are angled quite a bit relative to that line, and that's probably, so these lines over here are probably not the long wood fibers, the grain, so to speak. So just split it in half. It is important to split it in half so that you have equal mass on either side of the split, and that way it'll run straight. Ideally, we'd be able to split it in the other direction too, this way, and then we'd really know where the grain was. But you'd have to have a pretty amazingly thick board to be able to do that. So this is really only going to maximize it for one direction, and we'll have to just accept the other. So you could either split it again, or you could now start sawing parallel to that. So measure over your part size and make a line and just saw it on the table, on the bandsaw, or however you want to saw that. You'll probably get higher. I mean, this split amazingly straight and cleanly, but you'll probably get a better yield if you saw rather than split. This is not the best way to maximize your yield, but it is the best way to get really as straight a grain as you can in the parts. I have heard the thought a lot that quarter sawn lumber doesn't have a grain direction. It's absolutely not true. The wood has a grain direction no matter which side you view it from. It's just a matter of whether you can see that grain direction easily or not. And in maple, it's really hard to ever see anything in terms of the grain direction. So I had a bunch of parts sawn for baby rattles, and I just couldn't read it at all in terms of the grain direction. So there's also taking it from a log. Now I'm not gonna, if you look at the Greenwood video on the website, there's a whole bit in there on how to get this out of the log, and I'm not gonna dive into that today. We're gonna spend more time turning than we are splitting today. But you can get out parts that look more or less like this. They'll have a bunch of splinters on them, and these are things that you really want to get rid of, because they will whip you to death. So you can just take a hatchet or a draw knife and get rid of that. I will also say that this is probably a lot of dirt in there. This thing was sitting on the ground, and so I'm just going to shave that off so I don't ruin my lathe tools. You can turn any species of wood, whether it's an ideal turning wood or not. Turning is much more forgiving than the splitting process. And so some woods are really hard to get your parts out effectively by splitting. But you can turn anything. There are woods that are so-called, good woods for turning, and those are ones that don't chip as much. So oak is pretty good. If you're doing really fine details in it, they will tend to chip. So I don't use it for baluster turnings, though I have done it, and it'll work okay. Things like fir are really chippy. That soft line in the fir and the growth ring, it would be boy, I'm blanking on this now. The early wood is soft. I don't remember what it is in any rate, whichever part of it's soft. It's different between the softwoods than it is the hardwoods, and I can't remember. Just tends to chip a lot, and so you get these little speck bits coming out of the surface of your turning that isn't great. The skew won't have that problem, the gouge will, but you can turn almost anything. For chair making, I tend to use oak, ash, hickory for double bobbin turnings. Hickory can even work okay for baluster turnings, but then maple would be the ideal, and that was the wood of choice for turners in the 18th and early 19th century. So we've got our perfectly straight grain piece of wood here. We need to get it in the lathe, but the first thing we need to do is actually mark it so that the center doesn't come out. And so we'll take a drive center and just sort of eyeball it on the end here. And we want it not necessarily centered on this end, but centered over where the major diameter of the part is going to be, which could be the same place, so it would be centered on the end and where my fingers are down here, if the part was straight. If the part's crooked, you'll need to shift this off center on the end so it looks like it'll be more or less centered down here. It doesn't have to be perfect because we'll just fine tune it later in the lathe. But you can just sight down the length of it and see this one's perfectly straight. I even got a dead ant on it. Perfectly straight. And so we'll just put it centered on the end. So I'm just looking to see if I have the same distance between the side of the drive center there and the side of the piece of wood, as well as over there on all four sides. So then take your wackerdoodle, drive it in, okay? And you'll do that for all your parts. So knock it out, go get your next part, do that over and over again. And then go over to your lathe. So we'll need to put down the drive center and pull this back so it'll fit in the lathe. So I've got wing nuts down here that loosen it, and just move that out of the way. So put it in the drive center, turn it to where the marks line up with the spurs on the drive center. We'll loosen the tailstock and slide it forward and tighten it, and just barely tighten the little crank there to where it's just loosely in there. Now we're going to set the tool rest to where the piece of wood is just barely clearing it. So tighten that down. You want the tool rest parallel with the center, so the same distance between the center of this center as the center of this one down here. And that'll help you make a cylinder and not a taper. Okay, so now we want a way to, oh, I tightened it down on my ruler here. That's not good. There we go. We want a way to know whether this is actually going to make or not. Is it centered? And so this is a trick that Curtis Buchanan taught me, along with everything else I know about turning, except for the stuff that Dave Sawyer taught me, who is the person that came up with this trick, I believe. So you just measure from the tool rest over to the part, and you want to do that at the location where your major diameter is. So if you're making a double bobbin part, let's say my major diameter is there, my biggest diameter, And so I'll measure at that point. So I'm going to measure between the surface of the tool rest there and the surface of the wood there, and I am at 1 1/8 inches. So now I'm going to rotate the piece of wood 180 degrees and measure that. Well, I'm 1 1/16 inches. That's pretty darn good. If it was off 1 inch, if it was off 1/8, I would think about moving it. Now let's look at the opposite two planes. So here I'm at 1 1/8 inches again, and the opposite plane to that is 1 5/16 inches. So that's worth thinking about. So I want to shift it towards me a little bit so that it's centered this plane. We already had it centered in what is now up and down, and we're centering it the other way. So that's 1 1/4 inches. That's 1 3/16 inches. I'm going to call that good. Now you crank this up really well. And which gets us to a little bit about safety. This is one of the more dangerous tools in the hand tool woodworking shop. It's not all that dangerous, but there are some things that can go wrong with it. One of them is if you don't tighten down your tool rest, it can go in flying into your work, and that's kind of exciting. Usually it doesn't result in any damage, but one of the things that can happen is the wood comes out of your lathe. It's a pretty obvious one, and so you really want to make sure your tailstock is locked down tightly. You've driven this thing in far. You have marked your centers. If you don't drive them in that step I showed you first, it's more likely to come out. You also want to make sure that your drive center has a point on it that's sticking out past the spurs, which is kind of like a safety mechanism. If you look at this spur center here, you can see the point is proud of these driving spurs a good bit. And so if it slips, it's still in the lathe. This point will hold it in. So that's important. Another thing you want to pay attention to is clothing. So I have twice now gotten my sleeves caught in the lathe. And if your lathe is powerful enough, these sleeves will wrap around that piece of wood and jerk you down here like this till this piece of wood's rubbing on you, and you're wondering where the heck the power switch is, and you've got this big old burn on the side of your arm. I haven't done it in a while. It's not recommended. It really puts a damper on your day. So roll up your sleeves. Necklaces, long hair, anything that can get caught in the lathe. Your necktie, if it's coming loose, you got your bow tie on for your turning. You just want to make sure that none of that's going to get caught in there. So that's really important. You'll notice that almost none of the safety things I'm going to mention actually have anything to do with these tools. There are catches and things that seem really scary, but when you're turning something that's only 2 inches in diameter, there's really not enough force for anything to hurt you. There's a school I've taught out, the John C. Campbell Faux School, where there's a skew chisel mount embedded in the ceiling as a joke, but they had to drill a hole to get it up there. It did not come flying out of your hands, and so that's really not one of the issues. The other issue that I will mention is you want to wear eyeglasses, especially when you're roughing down a cylinder. There's just so many things, and well, here's one, a splinter that's loose, and that can come flying out at you. It can also pull up like that and whip you to death as it's going around at 1,000 RPM or 2,000 RPM. So you really want to make sure all these things are loose. I keep a draw knife hanging right above the lathe, and I'll just take those off real quick. You can also kind of stick your skew chisel in there and pull them off, or whatever you want to do, but get rid of all these fibers before they cause a problem. I just noticed that I missed. So I've got my drive center tightened up, but it's not in the holes that I made when I drove the drive center in to begin with. So I'm going to rotate it around so they're actually going into those depressions. That should be better. Okay. And of course, the only other thing is sanding dust, which really we don't deal with that much because we're not sanding. I rarely sand my turnings. Every once in a while I get into a spot where I do. You'll have to sand them more if you're using boards than you will if you're using riven wood because you just can't get the perfectly smooth finish sometimes.